Okay guys, let's take this Skyhawk up and work through the flight controls and demonstrate their effect on the attitude of the aircraft, its pitch, roll, and yaw, and how it moves around the axes. Taking off from Abbotsford Airport, runway 07. All right, we'll use a little bit of pitch to rotate around the lateral axis and start our climb. This isn't really a flight lesson, more of a demonstration. All right, and if you do flight training at Abbotsford, we generally head out to the what we call the Eastern Practice Area between Abbotsford and a little town east of Abbotsford called Chilliwack. So again, taking a look at our cockpit here, you know, we have our yoke, which if we turn left and right will affect our ailerons, giving us roll. I think you can see outside how the aircraft is rolling. We have elevator connected to the horizontal stabilizer, which is going to allow us to pitch the aircraft. And then we have our rudder pedals, which moved left and right will yaw the aircraft. So from inside the cockpit, this is what, you know, roll looks like. This is what pitch looks like. And this is what yaw looks like. So we're at 2,000 feet. That's a pretty good altitude to work through these maneuvers. We'll pull our throttle back a little bit, decrease our engine RPM. It's always good to be nice to your engine. And let's take a look outside. All right, so let's take a look at that aileron movement. And we can watch the aircraft yaw. So you can see that just ever so slight. Then the faster we go, the less aileron movement is required, because speed is one of the biggest components of lift. In fact, in our lift equation, velocity, it's velocity squared. So it has a very large, has an exponential effect on lift. So the slower we go, the more aileron we need. The faster we go, the less aileron we need. So there's an aircraft just rolling left and right. And as you notice, the major movement in the turn of an aircraft, the aircraft is going to turn, is to roll the aircraft. We're going to need a little bit of yaw to help us smooth out that turn, though. All right, well, let's go ahead and take a look at our horizontal stabilizer. Our elevator. We can watch the movement it makes for pitching the aircraft. All right, so there's the aircraft pitching again. It's around its center of gravity on the lateral axis. So this is the lateral axis that the aircraft is pitching around. And finally, we have our vertical axis that's affected by our rudder. So as we move our rudder left and right, the aircraft yaws. So there's yaw. And you would hate to be in that aircraft right now. It would not be a comfortable ride. There's pitch. And here's roll. So the same things that you can achieve with your model or paper aircraft, we're achieving here, you know, through the control surfaces, so we can control the aircraft the way we want to control it. And if we do all these things nice and smoothly, you know, the aircraft makes nice coordinated turns, climbs and descents, and you do work all these controls together. So we add a little pitch, we add a little yaw, our little rudder, we add a little aileron, a little roll to smoothly control the aircraft. So all three control surfaces work together, and all three control surfaces are needed because of what happens to our lift on the aircraft. When we take a look at our aircraft from the front, let's level off here a bit. You can see that except for the slight dihedral in the wings, our lift is at right angles to the ground. So our 100% of our lift is being used to give us distance from the earth. Notice as we roll the aircraft, some of that lift, and let's just go ahead and we'll just pause it here. Some of that lift is not pointed towards the ground. Some of that lift is pointed towards the horizontal. So we're losing some of our lift from the earth. So to compensate for the loss of that lift in the turn, because some of the lift is going horizontal, we have to increase our elevator or increase our pitch. So increasing our pitch will point the nose up. It'll direct and vector our thrust upwards, and thus providing us with a turn where we don't lose altitude. So if we don't do that, in a turn our aircraft will actually lose altitude, and we can demonstrate that by not adjusting the pitch of the aircraft in this turn. If we go inside, you can see our altitude is decreasing as that bank continues, and some of our lift is vectored to the horizontal. As we roll out and go level, you can see immediately the lift that we have been vectoring to the side is now vectoring directly towards the earth, and we enter a climb. So again, just as in your paper airplanes or a model aircraft, we want our airplane to do a certain task, to fly a certain way, a certain direction. It's incumbent upon us to use all the control surfaces together in order to achieve the type of flight, the direction of flight, the duration of flight that we want through. For instance, if we are flying an aircraft that's a boomerang aircraft, we don't want it to lose too much lift, we may go ahead and give it a little bit of up elevator as the aircraft turns and comes back to us, so it doesn't turn and continue to spiral towards the ground. So there you go. That's taking our control surfaces from our first lesson, putting it together to show you how those work in our aircraft in flight. So we'll be back with another video. We're going to use some bigger aircraft to show you the similarities, how all aircraft still have the basic major control surfaces and perform a maneuver in the same way.